Good morning, distinguished colleagues. I hope that now everything is better. Let's start from the very beginning. I'd like to represent you the report on detecting autonomous systems relationships and the priorities here. First of all, let's speak about classification of AS. There can be different classifications, and all of them are important. But let's start from the unserious option. Well, distinguished technical support, why do you give the wrong presentation? I'm really becoming a fan. The name is the same. We can use. Maybe it is me who is wrong, and I don't recognize my presentation. So okay, let's do with this. This quiz is for the help my presentation, and at the end we're going to have the answers for all the questions. Let's start from the very beginning. Why we need AS relation and policy discovery. As I said, the classification of systems can be different. So the AS can be divided into traffic generators. The income traffic is much bigger than outcome, so the balancing of traffic is the main goal. And another type of the systems is traffic consumers. Their goal is vice versa, to balance the external traffic. Such classification is not a usual one, but I'd like to stress the fact that for all AS, if the income traffic is big, then we need external balancing, and we need to know how the traffic goes, and here we face problems. The problem is evident. The traffic is asymmetric. It is asymmetric because of money. Where one can get more, the traffic goes there. It is implemented by routing policies and priorities between AS. So we can answer the first question, why we need AS relation policy discovery. We needed to get opportunity for intellectually balancing external traffic, and also for AS design. For the last 10 years, there have been a lot of projects which were opened and which provided us with data about the relations in the internet. Let's speak about them shortly. Everything starts with the stars and the sky. It is very bright, very beautiful, but unuseful. We cannot use this for any analysis. Then we went deeper, and we see that the autonomous systems are different. There is a center, there is a spearing connectivity. It is a deeper analysis, but from the applied point of view, it is quite unuseful. And what is the best? It is ROPTEX servers and Hopcan electric servers. They use data from BGP, but the traffic prediction here is from Hurricane Electric. It is a kind of the home of the Spider-Man, and we cannot use this for solving some practical issues. But let's speak about the core of the problem. All in all, there are approximately 300 or 400,000 links between ACEs. And at any given moment it can use 100,000, but it uses just 50,000. So we must define the ways which we can use and what ways are used at any given routing policy. When I started this project, I faced the opinion, why do we need this? There are physical links and they are obvious. There are data from routing registers, and let's take the chart from these registers. But unfortunately, it is not so simple, because the data at the router registers, including RIPE, are different. They are not full and they are not up to date. We can use them, but the chart doesn't have anything in common with the real life. So we are facing this barrier. The main project is to detect the links at the physical level, and we cannot use this registry chart. So the intellectual balancing and traffic prediction is impossible. Seem to be impossible. And this challenge was the main reason why we come to this issue at Project NF, our autonomous system and filtering system. We had a goal. Our system should be balanced. We can switch the traffic between different fields, between different platforms, and we should have possibility to calculate all our moves of traffic, so that we try to minimize the expenditures. Now the AS design, that is money multiplied by time. We used our own formula, so we spent the same amount of money and much more time, but we didn't use it for administrative work, but for creation of innovative model. What are the components? Is detector of relations, active verification. We also can define priority at every level of BGP decision process, pre-policy, and the lower priorities, which we join to one static priority. Let's speak about some examples. We have a couple of examples. These are the most simple examples. That is, I kind of told about it. For example, we have a graph, and we know the announcing direction in the AS. And we know that the link between AS3 and 4 is P2P. Using this data, we can say if AS3 is 4, let's AS5 go through, the AS4 is a customer of AS5. Then we can look at the whole graph total. The second example is active verification example. It is the easiest way. Let's make a trace route. One remote node is one trace route, and we need a lot of external nodes to cover the whole internet, and it is not an effective measure. Therefore, we changed the utility of traceroute with a pink traceroute with a spoofed IP, and one node has a cover for all neighboring systems. We send an echo request, and the echo reply comes back to us. And for one node, we have not one trace, but n traces, where n is the number of neighbors. So I said what we have done, and now we have just one question. Why do you need this? It was a kind of critical question. Therefore, we launched a portal, Qrator Radar, which provides an opportunity to use the results of our modeling online. There is information on AS relations. It gives you the picture of how it changes in dynamic. Then we have an opportunity to see BGP Route Prediction by changing Prepend Policy, and also you have an opportunity of AS design. Let's speak about it each point. So we discover the whole world in relation to our AS relations. We have 3 suppliers. For other systems, this dynamic is more evident. This dynamic can be seen. The second point, it is much more interesting. It is how it is announced from us to the suppliers. It is it can be seen for any system, and to the right you can see the changes of this route when we change the routing, when we stop the announcing through prefix HTTP, and you can see the changes in the system. We can change the policy for stake standards, and we can see how the graph changes, so how the traffic goes. For those who can log in at the site, you can see a modeler. We use as a basic AS, system or another system, and we can add additional provider and see how it changes, how it influences on our graph. Maybe we can see that how it doesn't go maybe from Atera 1. And we also focused on security issues. A year ago I told you the Enog, and it is accessible at the public for any logged user. These are vulnerabilities of the system, and the full disclosure is available for technical context of a certain AS. The information about vulnerabilities and anomaly is available to all the users, and you can see the changes of the security issues. The last update led to a kind of a little crash of the system, and so, but it will be restored. We work closely with net filtration, and we have the botnet map, and we can show the AS at which IPs there are machines with viruses. So we answered all the questions, and I must say what we are going to have in future. We're going to have a drop detection. We know how the traffic goes and define whether the drop influences this whole system, and we have an opportunity of system monitoring. It detects the problems of system and how we can overcome this problem. So probably that's it, and if you have any questions, please, you are welcome with them. Okay, thank you. What questions do we have? Maxim Rajewski, Vera, Alexander. Well, the website is very problematic, and I want to kill the designers of this. We looked at our autonomous system, and we have 2 observations. The op strings, we didn't guess about them. we did guess about that, and about peerings we did not guess. We could see only public peerings and not private peers. There are such peerings about which I hear for the first time. But it can be interesting for you, because what we see, it is what the route reflectors see. And if you are surprised by the ways, by the routes you see there, then it can be interesting for you. Well, look here. I think that the public route servers at the IX, you do not take them into consideration as peers, as peerings, while you take into consideration the participants of route servers. I do not look at the IX data. Well, about the algorithm. The algorithm is the following. We collect the data, BGP charts, route reflectors, and IX, and then we use this data to build these relations. There can be some errors, but as for the peerings, we don't have project peers. In the nearest future, we use the BGP peer, public BGP peer. Then we can see the peerings. Well, I'll ask you by email. There is another question.
Jim Cowie from Renesis. So thank you for taking on this challenge. This is a really difficult problem, and it's good to see people working on it. A question. If you're looking for paths between point A and point B, BGP is very good at showing the inbound preference, how I want traffic to reach me. Very often, an autonomous system will choose among 5 or 6 ways out, and that is not visible in BGP. What's your sort of theory for how to deal with that?
Спасибо большое за вопрос. Да.
Yes, thank you for your question. The BGP, there can be different paths, and we can define the priority, but we can use some features, for example, common clients. We can see what pad has the priority, even at the low level. And we can also define the priorities at the prefs. And therefore, we use active verification. Thank you. Another question? I have a short question. Why do you at Qrator Radar don't look at the IPv6? So for IPv6 net is unstable, and we just really didn't have enough time. We start with IPv4 and then we go to IPv6 because it is the way for everybody to go. So it is not a problem for you. Well, no, we do not avoid this or something like that. We just move slowly from IPv4 to IPv6. Thank you. Yes, I have also a question. Please, could you tell me your prediction system, was it tested at the dark spots in the internet? So maybe the part of the net which is badly connected to other parts. There is the traffic source, but you cannot define it. Did you see this? Did you face this problem? Well, could you explain me? Well, we didn't look for the dark material, but we can see the cycle of BGP routing. Well, I'm not about it. Let's imagine you have the connection. The connection of AS is different. In continental Europe, the cross connection is higher than in, well, than the connection between the northern China and Moscow. But in China, within China, is the average connectivity, which is quite the same. did you test your system for any sports where you cannot define the resource of traffic? Well, for this model, it is impossible to see it, and this tier 1 with TCMP and local connectivity, there is one in China, and we cannot see private peers. What is going, what the outcome goes through tier 1, and we see it. So when the TR goes, when it goes through the TR, bigger TRs, yes. Well, so what do you use for pinging? Why do you collect information on pinging? As I described, these are the ways of, these are the routes of BGP, the relations of AS, then the higher priorities, the upper priorities, the lower priorities, and the verification of the model, which is verified by eyes.
Спасибо. Как-то вы прям вот.
Thank you. Well, you're going nearby my question, but didn't get a direct answer. Okay, let's talk maybe the background. Viktor Savranov, could you tell me, please, how rapidly you receive this information and how this information disappears? How it appears, how it stores, and how it disappears. Well, general information, it goes on a daily basis, and we think that if the peer appeared there, then it considers this peer to be present for 2 weeks. If it is supplied Enog, then if you stopped using it, you announced it, then you stopped using it, then you will see it the next day. So in 24 hours. So while we see it, we have to find out why it is still there. When we talk about suppliers or providers, yes, that's right. And Denis Yusupov. And could you tell me, please, it's about the search in the dark matter. In your system, how it looks like, the situation which recently happened with Perifela, when it was something from Korea with false PGP, things like spoiling, and it looks to be like a noise for a model. We try to remove it, but it doesn't always happen. So I think once we will get to the issue, to find those issues and to clear them up, but at the moment it's just at the level of removing the noise.